In this video, we're going to go over the difference between consumer and producer surplus, and also how to calculate these two values using integrals in calculus. So let's start with consumer surplus. Consumer surplus is found from a demand curve. So a curve where we're looking at our x variable as quantity and our y variable as price. And a demand curve is negative sloping, so perhaps the demand curve looks something like this. So on our demand curve, which we're going to write as a function, demand with variable q, there's some quantity q naught and its corresponding price. If we go over to the y-axis, p naught, which is our equilibrium. So if the quantity is set at q naught, then the price is set at p naught, and the actual expenditures, or the amount of money spent by consumers, would be the area of this rectangle. And this area above the rectangle is what's known as the consumer surplus. And what the consumer surplus means is it's the amount that consumers were willing to spend, but they did not. So for example, if the quantity sold had been this value here, on our curve it corresponds with that point, and then here's some other price that goes with that Q. There were some consumers that were willing to spend this price, but they didn't. They spent less than that. So that's why this is called the consumer surplus, the amount that consumers were willing to spend, but they did not. So how do we calculate this consumer surplus? We're going to think of it in terms of an integral. So we can see that we could calculate the area underneath this curve here using the integral. That would be the area all the way from the curve to the x-axis. But we can calculate that using an integral. That would be an integral from 0 to q0 of our function d of q, dq. But that's not equal to the consumer surplus because the consumer surplus was just this triangular region above the actual expenditures. So we actually need to subtract the actual expenditures. And the actual expenditures, the way we could find those is, well, it is a rectangle, but if we want to think of it in terms of an integral, this line here is the constant function equal to p0. So the actual expenditures would be the integral from 0 to q0 of the constant function p0 dq. So our consumer surplus, since we have the same bounds here, we can write this as a single integral 0 to q0 of d of q minus the constant function p0 dq. And that's how we calculate the consumer surplus. So now let's look at the producer surplus. And for producer surplus, we're going to think about a supply curve. Which is usually a positive sloping curve. And again, we're looking at quantity and price. And if the quantity sold is Q naught, then the price that corresponds to that would be P naught. Okay, so this supply curve, let's call it the function S of Q, and our equilibrium is Q naught comma P naught. So now in this example, this whole rectangle is equal to the total revenue, because we're thinking that this quantity was sold at this price. So we do get that area of the rectangle. And then there's this little region above the graph still within the rectangle. This is the producer surplus. And what the producer surplus means is, well, that means the amount of money that producers gained or have in surplus because they were able to sell something at a higher price than they needed to. So what that means is, let's say that this was our Q. Consumers were willing to pay this price at that quantity sold, but they ended up paying this price instead. So that's how we get this surplus, this producer surplus. And again, we're going to be able to calculate it using the integrals. So we're also going to need this region here, which is just the area under the curve. So the total revenue is this whole rectangle that I've shaded dark. Producer surplus is the red, and then the area under the curve is the blue. So the producer surplus is going to be equal to the total revenue minus this blue area, or the area under the curve, which is integral from 0 to Q0 of S of Q dq. So the total revenue, we can think of that as a constant function, the constant function P naught, so that would be integral P naught dq, 0 to Q0. And that's going to give us that the producer surplus, if we combine these two integrals, since again we have the same bounds, is integral 0 to Q0 of P0 minus S of Q dq. So this is just an overview of what consumer surplus and producer surplus are. In the next video, we'll go over an example of how to actually calculate these.